Example 3 wants us to work with an equation of an inverse as well as restricting domain. This is a really interesting question. 30-1, pretty specific to this curriculum. It's the only course I've ever seen an interest in doing this kind of thing. So here's what ends up happening. We have an original f of x called y equals x squared minus 2, which has been nicely drawn for us over there. Now, when the reflection happens, you can imagine this entire graph is going to kind of be pushed on its side when all that domain and range gets switched, the x and y's get switched. I can kind of already predict that the graph is going to have this kind of appearance. Now, here's what ends up happening. Here's a common outcome. So we take the inverse. So we switch x and y. It becomes x equals y squared minus 2. Remember, we want to switch x and y, and we're already now looking at an inverse equation. But this inverse equation is not, it's not y equals. It's not set up like a real equation, like what we would want. So we have to solve for y. We have to dig it out. We have to move this equation around. And so as I start rearranging this equation, I get to a really important moment. Now, very, very commonly in the classroom, this is just bound to happen. A lot of people say, well, I got to get rid of that squared, so I got a square root, and therefore I get the equation called square root of x plus 2 is equal to y. Now, the bad news is this is what the square root of x plus 2 looks like. It's just this positive top radical function. And look, like that's not the reflection anymore. It's like we're missing a big part of our inverse, because the inverse is supposed to be a reflection. I mean, you can't just get that stuff doesn't just disappear. It's not a really good mirror. That's not what we're looking for here. The fix for this is to know that when a root is pulled out of thin air, when a root is used to solve a degree 2 scenario, for example, it's not just the normal root. It is both the positive and the negative root, which is this is actually the correct equation, the full equation of the inverse. Because not only does it produce that top half, but it also produces this bottom half, which is the negative of the root x plus 2, and that's the full reflection. But we have a problem that this is not a function anymore. Look, it fails the test. Vertical line is touching too many times. So they're saying, well, let's fix this. Could we fix this? Is there a way to restrict the domain of the original so that the inverse doesn't suffer this terrible fate? And what they're hoping that we can kind of catch on to here is that at the moment, the original, let me redraw the original. The original is pretty wide open. I mean, we're allowing the original to go forever to the right, forever to the left. So there are no restrictions. That they want a restriction, but currently there are none. XER is another way of saying that there's no restrictions. Now, what this is doing is it's causing a little bit of drama in the math world. So it's creating this inverse, which is both the positive and the negative equation. So our goal here, our hope is to restrict this graph. And what a restriction could look like could be to say, what happens if we somehow were able to erase or get rid of a good part of the original, like half of the original, for example. And I was to say something that says we're only going to keep this part of the graph. I'm only going to keep a part of the graph. Now, it really doesn't matter which part you keep, but as long as you keep a small enough piece, the reflection will work out. Because if I was to somehow cancel that left piece, what I'm effectively doing is canceling the bottom of the reflection and only keeping the top half if I'm keeping the right half. And then everything would kind of check out. So in order to get rid of this piece, I have to modify this domain. I have to put a restriction. And a statement would be to maybe just say the new domain. And so to say, I want to keep only the positive side, only when x is greater than or equal to 0. That's called a restriction because we're not letting it go left and right forever. We're kind of imposing our will. And so that has the effect of eliminating a good chunk of the inverse reflection. All is good. Everything passes the tests. And that is kind of a really specific skill and question we're hoping that you can be on top of.